In part A, we're asked about two patients and the probability that one or the other has a scan done. So we will call these events scan for person 1 and scan for person 2. So we want to know the probability that S1 happens or S2 happens. That is, that the first person is scanned or the second person is scanned. Now, there's really no importance of order here. We're just numbering them just to distinguish one person from the next. So that means we want to find, the probability of S1 plus the probability of S2. So probability of S1 plus the probability of S2 minus the probability of S1 and S2. Now, of course, we don't have this number right here. We don't know the probability of both of two people getting a scan done, but if we can assume independence, the fact that this happens, that one person gets a scan, probably should not affect another person getting a scan, reasonably speaking. And plus, we don't have any more information on that, so the best we can do is to assume independence. So this number is 0.2, this number is 0.2, and now under independence, it's just the product of the probabilities. So that'll be 0.2 times 0.2, the probability of first person scanned, probability of second person scanned, and plugging this all in, this is 0.4, this is 0.04, the difference is 0.36, 36% chance. In part B, we're looking at the likelihood of treatments being unnecessary. So a single patient, now it doesn't matter that they're two different patients or one patient, because we assume the events are independent of one another. So U1 is the event that the first test was unnecessary. U2 will be the event that the second test was unnecessary. And now what we'll do is take the probability of U1 or U2, which is the sum of the probabilities as before, minus the overlap, U1 and U2. And similarly under independence, we can write this as 0.33, which is basically just 1/3 as a decimal, so that's 0.33 right there, plus 0.33 minus 0.33 times 0.33. So we will consult our calculator on this one, plus 0.33 minus 0.33 times 0.33, or you could just do 0.33 squared for that last term. And it gives us 0.551. So this is about 0.55, about 55% chance. So pretty likely that two tests, at least one of them is unnecessary. In part C, we're asked about a patient who's prescribed a scan and a blood test. What is the probability that an unnecessary prescription was made through the patient's eyes? Well, that's going to be when a scan was done to protect the guy from the lawsuit, or a blood test was drawn for unnecessary purposes. So that's going to be basically the probability that the scan happened, or the, gotta be kind of careful here with our union sign, or the blood test was simply unnecessary. So remember, these are both instances that the patient does not want to arise, because here he's getting a scan done just to protect the doctor from a lawsuit. Here, the blood test is just simply unnecessary. So that's going to be the probability of a scan plus the probability of an unnecessary test minus the probability that the scan was to protect the doctor and the test was unnecessary. So that's going to be 0.2 plus 0.33 minus, again under independence, we're assuming that the test and the scan maybe were not related. Maybe that's not a good assumption again, but we have to make it because we have limited information here. So we can basically get at a approximation at least. So we're going to type this in, 0.2 plus 0.33 minus 0.2 times 0.33. Oops, I have an extra parentheses there. I'll just close it twice over here. And so that tells me that there's a 46.4% chance that either the scan was unnecessary or the blood test was unnecessary.